Good morning, students. Previous class we have solved some problems related to linear differential equation and its examples. Now let us work out the examples on the method of variable separable method. So the first question, express the following differential equations in the form of f of x dx plus g of y dy equals to 0. This is function of x and function of y. Variable separable method. So the first question is dy by dx equals to 1 plus y square by 1 plus x square. So this can be written as dy by 1 plus y square is equals to dx by 1 plus x square. Just a cross multiplication I have done. And now this can be written as dx by 1 plus x square minus this on transposing to another side, this plus will become minus. So this is plus minus of dy by 1 plus y square equals to 0. This is clearly of the form, this is function of x plus this is function of y. So this is of the form, it is in the form f of x dx. So where f of x is 1 by 1 plus x square. So plus function of y is minus 1 by 1 plus y square. So g of y dy equals to 0 where f of x equals to 1 by 1 plus x square and g of y is equals to minus 1 by 1 plus y square. Now the second question is y minus x dy by dx equals to a into y square plus dy by dx. So this can be written as y, this is a into y square. So plus ay square, if you transpose on to another side, minus ay square is equals to, this is a into dy by dx, this is a dy by dx. This is minus x into dy by dx. If you transpose on to another side, this is plus x dy by dx. So this can be written as, so y into 1 minus ay is equals to, if you take dy by dx as common in both of them, then we'll get a plus x. So now this gives rise to this is a plus x by dx. If you transpose, then it will be dx by a plus x, dx by a plus x. This is equals to dy. This is multiplying. If you transpose onto another side, it is dy by y into 1 minus ay. So this can be written as dx by a plus x plus minus 1 by y into 1 minus ay dy equals to 0. This is clearly of the form. This can further be written as 1 into dx. This is fx dx plus g of y dy equals to 0. And if you see the third question, this is dy by dx equals to this. This can be written as dy by dx is equals to, this is e power x by e power y. A power m minus n can be written as a power m by a power n plus, this is e power minus y can be written as 1 by e power y. This is x square by e power y. This is dy by dx equals to, if you take e power y as an LCM, then we'll get e power x plus x square. So if you cross multiply, this is e power y dy equals to e power x plus x square dx. So therefore, e power x plus x square of dx If you transpose this onto another side, this is minus of. So this is plus into minus of e power y into dy equals to 0. Therefore, this is clearly of the form f of x dx plus g of y dy equals to 0. So now let us work out the fourth one. So which is dy by dx plus x square equals to x square plus e power 3y. So for that, so fourth one is dy by dx is equals to x square e power 3y. This plus x square, if you transpose onto another side, it is minus x square. Take x square as a common, then e power 3y minus 1. So this is equals to dy by dx. So this can be written as dy by e power 3y minus 1 is equals to x square dx. Just have done the cross multiplication. Therefore, this is x power 2 dx. This is plus, if you transpose onto another side, it is minus. So this can be written as plus into minus 1 by e power 3y minus 1 dy equals to 0. It is clearly of the form f of x dx plus g of y dy equals to 0. So we have succeeded in separating the variables and write it in the form of f of x dx plus g of y dy equals to 0. So the next question is x plus dy by dx equals to 0. Find the general solution. Find the general solution of x plus dy by dx. So this can be written as x plus y into dy by dx. First of all, this can be written as x is equals to minus y into dy by dx. And this is equals to, on transposing, x into dx is equals to minus y dy. If you transpose here, this is plus y dy equals to 0. Now, this is clearly a variable separable method. So, because this is x dx is equals to minus y dy. So, x on one side and the variable y on the completely other side. And if you bring here, then it will be plus. Now, integrating, we get integral x dx plus integral y dy equals to 0. Integral x dx is, it is of the form integral x power n dx, x power n plus 1 by n plus 1. So this is x square by 2 plus this is y square by 2 is equals to, so integral 0 dx. Otherwise, so actually the constant of integration is what we are getting at the end. Let us write it as c. Therefore, if you take a 2 as an LCM and transpose on to another side, it will be x square plus y square equals to 2c is the required general solution. Now, let us do the third problem. So the third problem is find the general solution of 3 dy by dx is equals to e power x plus y. So this can be written as solution. So this is 3 dy by dx is equals to e power x into e power y, because a power m plus n, a power m into a power n. So this is equals to 3 dy by e power y is equals to e power x dx. So 3 dy I kept it on the LHS itself, and e power y is multiplying with e power x. But when we are bringing this term onto the opposite side, then it is multiplying, it would be dividing, and this is e power x is intact. So 1 by dx, if you transpose onto another side, it is into dx. So, or it can be written like this also. So this is dy by e power y is equals to 3 into e power x dx. So 1 by 3 into this 3, if you transpose onto another side, it can even write like that also. Now integrating on both sides, this is 3. I am separate from the process of integration. 1 by e power y can be written as e power minus y dy is equals to integral e power x dx. So 3 into integral e power minus y is minus e power minus y is equals to integral e power x dx is e power x plus constant of integration at the end plus c, or you may even write e power c also. So this can be written as e power x plus 3 e power minus y plus c equals to 0 is the required solution. So the next question is, find the general solution of y square minus x dy by dx is equals to a into y plus dy by dx. So we need to find out the general solution. This is the question number 4. Y square minus x into dy by dx equals to a into y plus dy by dx. So this is equals to y square. This is a into y plus ay. If you transpose onto another side, minus ay is equals to, this is a into dy by dx. This is minus x dy by dx. If you transpose onto another side, it is plus x dy by dx. So this can be written as, if you take y as a common, then 1 y minus a. So this is y into y square minus ay. So here dy by dx, if you take common, then this is a plus x. So separating the variables, we get this is a plus x by dx. If you transpose onto another side, this is dx by a plus x. This is equals to, this is y into y minus y. So this is dy by, if you transpose this onto another side, it would be dividing with the dy. So y into y minus a. So now integrating on both sides. So this is integral dx by a plus x is equals to integral, or it can be written as 1 dx. This is 1 by y into y minus a into dy. So how do you solve this? This is integral 1 by x dx type. Therefore, this is simply log mod a plus x. But as far as this is concerned, we have to apply the variable, we have to apply the partial fractions. So here y and y minus a are the two linear factors, and this is a proper fraction because degree of numerator 1 can be written as y power 0, and this is y into y square. So degree of numerator is 0 whereas degree of denominator is 2. So degree of numerator is less than that of degree of denominator. Therefore, it is a proper fraction. For proper fraction, partial fractions can be applied. So let us consider this. So take 1 by y into y minus a. So this can be written as a by y plus b by y minus a. So this is equals to 1 by y into y minus a is equals to LCM is y into y minus a. So therefore this is a into y minus a plus b into y by y into y minus a. So this gets cancelled on both the sides. So here y and y minus a are the two linear factors. Substituting y equals to 0 and y equals to a to obtain the values of a and b. So substituting, put y equals to 0, that implies 1 is equals to a into, in the place of y substitute 0, 0 minus a, this is minus a. So b into 0, 0. Therefore this is simply a is equals to minus 1 by a. Likewise put y equals to a, then this is 1 is equals to a. If you substitute in this, a minus a, this is 0, so b into a. So this is equals to, b is equals to 1 by a. Therefore 1 by 5 into 1 minus a equals to, the value of a is minus 1 by a by y, a by b by c, a by bc. So a into y plus b is 1 by a. So 1 by a into y minus a. So now, so this is equals to integral 1 by a plus x dx is equals to integral. The value of this is equals to this. So therefore, if you take 1 by a as common in both of them, then we will get 1 by y minus y minus a minus 1 by y. See, in both of them 1 by a I have taken common. So this is 1 by y minus a minus 1 by y. So now this is equals to this, and integral dy is this integral dy. See, integral dy I have written the same. So 1 by y into y minus a value is this. So in between integral and dy, so I have written this. Now what is integral 1 by a plus x dx? This is log modulus of a plus x. This is 1 by a. If you take aside from the process of integration, since it is a constant, 1 by a into, this is log y minus a minus, this is log y, because this is integral 1 by x dx is log mod x, integral 1 by y dy is log mod y. So this is equals to log a plus x is equals to 1 by a, log a minus log b is log a by b. So this is log y minus a by y. So this is m log a, m log a, log a to the power of m. So this 1 by a can be written here. Now This is equals to a plus x equals to y minus a by y whole power 1 by a. So if you uh, do power a on both the sides, this gets cancelled. Therefore, we get that a plus x whole power a into y is equals to y minus a is the required general solution for this differential equation. Now, the next question is, now let us solve the fifth question. Find the general solution of dy by dx is equals to y square plus 2y by x minus 1. So again in this question also he is asking to find the general solution. So first of all, can we express this into the variable separable method or not? Obviously, because the whole equation is in terms of just x and y. So we can separate the variables easily. Separating the variables and integrating on both sides. Then we'll get this is dy by y square plus 2y is equals to dx by x minus 1. Just transposed. So this is dy by y square plus 2y. This dx I have transposed onto the another side. So dx by x minus 1. So now this can be written as 1 by y. If you take common, then this is y plus 2 dy is equals to, this is dx by x minus 1. So this is equals to, consider 1 by y plus 2 I will consider. So this is again a proper fraction. So partial fractions can be applied and the denominator contains two non-repeated linear factors. Since two non-repeated linear factors are there, so we have to take two constants into consideration. Therefore, this is a by y plus b by y plus 2. So this is equals to 1 into a into y plus 2 plus b into y. So put y equals to 0. Then 1 is equals to a into, this is 0 plus 2 is 2 only. Therefore, this is equals to a is equals to 1 by 2. Likewise, put y is equals to minus 2. So this is equals to 1 is equals to minus 2 plus 2. This will be 0. This is b into minus 2. So b is equals to minus 1 by 2. Therefore, 1 by y into y plus 2 is equals to, this is, a value is 1 by 2 by y. So 1 by 2y. So b value is minus 1 by 2. So this is plus minus 1 by 2 into y plus 2 is 2 into y plus 2. No. So this will integrating on both sides. Integrating on both sides. This is equals to integral y into y plus 2 dy is equals to integral dx by x minus 1. So for this, I have applied integrating on both the sides. That's it. So this is equals to integral dy. Between integral dy, 1 by y into y plus 2 is equals to how much? This. In both of them, 1 by 2 is common. So let us take 1 by 2 as aside. So 1 by 2, if I take it aside, then we will be left with 1 by y minus 1 by y plus 2 into dy is equals to, this is 1 by x minus 1 dx. Integral dy, between integral dy, 1 by y into y plus 2 is this I have written, and 1 by 2 I have set it apart. So this is equals to 1 by 2, integral 1 by y dy is log y minus integral 1 by y plus 2 dy is equals to log y plus 2 is equals to integral 1 by x minus 1 dx is log mod x minus 1 plus constant of integration c. Instead of c, can I write it as log c also? So we can, because this is whole is in terms of log, therefore I thought it convenient to write log c instead of c. So this is it, and that log c can even be added on the LHS also. So we have to add one of the either sides. So this is equals to 1 by 2 log a minus log b, log a by b. So this is log y by y plus 2 is equals to log x minus 1 plus log c. This is equals to m log a is log a to the power of m. So this is log y by y plus 2 whole power 1 by 2 is equals to log a plus log b, log ab. So this is log c into x minus 1. So if you remove log on both the sides and if you square on both sides, then whole power 1 by 2 whole square gets cancelled, will be left with y by y plus 2 is equals to, this is c into x minus 1 whole square. So whole square. So log I have taken and we are left with y by y plus 2 whole power 1 by 2 equals to c into x minus 1. So I have squared on both sides. Whole power 1 by 2 whole square gets cancelled. We are left with this. This is c into x minus 1 whole square. C square x minus 1 whole square. Therefore, we have got y is equals to c square. C square can even be written as c or k. So if you write a c square even, it is also not wrong. So c into x minus 1 whole square into y plus 2. Y is equals to is the required general solution of dy by dx equals to y square plus 2y by x minus 1. So now let us see the next question. Dy by dx is equals to x into 2 log x plus 1 y sin y plus y cos y. So we need to find out the general solution for this. First, as usual, we will separate the variables on both the sides and integrating on both the sides, and at the end C can be added one of the either sides. This are the three steps that we have to do. Solution. This is the sixth question. Now this is separating the variables. We get and integrating. We get this is sin y plus y cos y dy is equals to x into 2 log x plus 1 dx. I just cross multiplied. So this is equals to and integrating on both the sides. Now this is equals to integral sin y dy plus integral y cos y dy is equals to integral 2 into x log x dx plus x into 1 x. So integral x dx. So this is integral sin y dy. This is integral y cos y dy. And this is 2x log x. So 2 I have separated from the process of integration. X log x. This x is multiplied with this 1 also. So x into 1 x integral dx. Now this is equals to integral sin y dy plus this is product of two functions uv dash plus vu. Sorry, this is the product of two functions by parts in the integration. So here I let, so this is trigonometric function and this is algebraic function. So this is just nothing but x cos x type. So here the variable has been changed in y, that's it. So this is algebraic function, this is trigonometric function. I let whenever product of two functions we came across, then by parts method is to be used. So here there are product of two functions. So this here y is algebraic function and cos y is the trigonometric function. So first function into integral of second function dy minus integral of differential quotient of first function into integral of second function dx, but here y dy whole dy is equals to 2 into here x log x. X is algebraic function and log x is logarithmic function. I let. So here L comes first. So first function is log x here. First function f of x into integral of g of x dx minus integral of differential quotient of first function into integral of second function dx whole dx. So this 2 is multiplied with the whole, this everything, plus integral x dx. Now this is equals to integral sin y dy is minus cos y plus y into integral cos y is sin y minus d by dy of y is 1. Integral cos y dy is sin y. Integral cos y dy is sin y dy. So LHS is this outcome. This is equals to 2 into integral x dx is x square by 2 into log x minus integral of d by dx of log x is 1 by x. d by dx of log x is 1 by x. Integral x dx is x square by 2 dx plus integral x dx is x square by 2. This is equals to minus cos y plus y sin y. 1 into sin y is sin y. Integral sin y dy is minus cos. Minus of minus plus cos. Again, 1 into sin y is sin y. Integral sin y dy is minus cos. Minus of minus. So plus cos y. So this is equals to 2 into x square by 2 log x. Minus this and this gets cancelled. So 2 into this is into 1 by 2. Now integral x dx is x square by 2. So 2 is multiplied with this minus this is integral x by 2 dx. In that x by 2, 1 by 2 I have separated. 1 by 2 into 2 is this. Integral x dx is x square by 2 plus x square by 2. Since the process of integration is over, we need to add plus c at the end. So plus c. So now this is minus cos y plus cos y gets cancelled. This 2 gets cancelled. And this 2 gets cancelled. So therefore we get y sin y. Y sin y is equals to x square log x. This minus x square by 2 plus x square by 2 gets cancelled plus c. So this is the required solution for the given differential equation. Find the equation of the curve whose slope at any point xy is y by x square and which satisfy the condition y equals to 1 when x equals to 3. So in differentiation we have known that the slope at a point x comma y is nothing but dy by dx at x comma y is nothing but slope m. So given that so slope m at x comma y is dy by dx is equals to y by x square. So this is the slope at the point x1 y1. x1 y1 is x comma y. Therefore this is the slope. And slope is represented by the letter dy by dx. So difference of y by difference of x. This is equals to, now we can separate the variables. So separating the variables and integrating on both sides, we get dy by y is equals to dx by x square. Now integrating on both sides. So here we are succeeded in separating the variables on either of the sides of equal to symbol. So and integrating on both sides. So integral 1 by y dy is log y is equals to integral 1 by x square dx is minus 1 by x plus constant of integration c. So this is the required general solution. But the thing which discriminates this particular problem with the earlier 6 problems are, as far as the last problems were concerned, so he is asking us to find out the general solution. Therefore, this With this it ends. But here, and further it is, and which satisfy the condition y equals to 1 when x equals to 3. So, we want not a general solution but a particular solution at the particular values x equals to 3 and y equals to 1. So, put x equals to 3 and y equals to 1. Substitute in this, we'll get log 1 is equals to minus 1 by x value is 3 plus c. We know log 1 value is 0. So 0 is equals to minus 1 by 3 plus c. Therefore c is equals to 1 by 3. So if you substitute 1 by 3 back into this, we'll get log y is equals to minus 1 by x plus 1 by 3. So this is equals to minus 3 plus x by 3x is equals to log y. So therefore 3x into log y plus 3 is equals to x is the required particular solution. So now let us do the next question. Find the general solution. Find the general solution of y into 1 plus x dx plus x into 1 plus y dy equals to 0. First, let us separate the variables on both the sides. Separating the variables. Separating the variables and integrating on both sides. So this is 1 plus x dx by x plus 1 plus y dy by y is equals to 0. If you bring this onto another side, this is minus of. So that also if you bring here, this is plus. Now integrating on both the sides, this is equals to integral 1 by x dx plus x by x is 1, integral 1 dx plus integral 1 by y dy plus y by y is 1, integral 1 dy is equals to 0. Integral 1 by x dx is log modulus of x. Integral 1 dx is x. Integral 1 by y dy is log modulus of y. Integral 1 dy is y is equals to constant of integration c. So therefore this is log a plus log b is log ab. So this is log xy plus x plus y is equals to c is the required general solution.